Okay, everybody, welcome back. This is the project that we're going to be working on today, and it works just like this. We have each of these little bubble objects has an X and a Y location. The main thing we're going to be doing today, though, is looking at see how the program overall is laid out, and secondly, to change the X and Y component of each of the bubbles to a vector that will have its own X and Y component. Okay, the first file that we're going to look at is index.html, and so we're going to go ahead and add a new file. We've got to have a vector file. The vector file that I have is called jsvector.js, and so all I have to do is add any of the files that I'm using in this project have to be added here. So we'll be looking at this file in just a few minutes. So I'm going to copy this source. Notice that all of these source tags are inside the head. And I've got a new file, JSVector, and JSVector needs to be added in so that when I run HTML or index.html in the browser, I can find each of these JavaScript files linked in the head. The first place my code will go is in the main.js file. Notice that I've got a window.onload equals init, and so as soon as the window is done loading, it will trigger an onload event, and then I will go to init. Init is a function, and so very much like in P5.js, I have a function where everything's set up. In P5.js, it's set up in this function. It's called init. I'm going to style the canvas. On line 11, I'm going to give it a background color. Then I have canvas height and width. And I create my context on line 15. Context is equal to canvas.getContext, and so I'm getting a 2D context. Remember, the canvas is just a container. Most of the functionality of what I want to do in terms of drawing things onto the canvas happens through the context. Then I'm going to create a array of bubbles. So I shoot down on line 16. I'm going to create an array that's going to contain 150 bubbles, and down here I can see that load bubbles takes in the number 150 in this case. I create a local variable called bubbles, and then in my for loop I'm going to load these bubbles. I keep loading them. Just new bubble gets loaded into this guy, and then I return bubbles. Bubbles gets loaded into this variable on line 16 and then sent into my new game object when I create a game object. Notice that on line 4, the only global variables in this project are game, context, and canvas. As we get into more developed programs later on in the course, we allow only one global variable for the entire project. This one happens to have 3, and we'll show you how to get around that later on. In any case, as soon as I'm done doing all these initial things in init, then I go to animate. And animate is a kind of loop, but it runs at a specific time interval. So as soon as I have this request animation frame down on 28, after a certain amount of time has passed, a 60th of a second, I'll call this function again, and all I'm doing is I'm clearing the background and I'm updating the game. So when I make my game object, I'm passing in a reference to an array of bubbles, and I'm setting that on line 3, this dot bubbles equals B, and then I have game paused equals false. I want to add some functionality later where I can just hit one of the tiles on top and pause the game, and I have a new game area which has all the functionality. I'm not going to go into it in this project, but it basically creates a bunch of divs in a canvas and aligns them as we saw in the opening example. Then finally, this .update is a function, so the game is just going to be updated, and every time I update it, I'm just going to run through all of the bubbles, and I'm going to run the bubbles. Okay, so this is the way the program is running right now. I have an X component and a Y component for location, an X and Y component for speed. I'm calling that dx and dy. And so what I want to do is change these. And so I'll take these 4 lines of code, and I'm going to say this .loc for location, and I will say that is equal to, and I want to have a new vector. So I say new JSVector. And JSVector, by the way, is an object. And so I'll show you that code in a little bit, but right now I just want to pass in the X component and the Y component. The real beauty of the vector constructor function is it only has these 2 variables. It's a 2-dimensional vector, but it does have about 20 or so functions that we're going to use to make things move around very nicely on the screen and do other things that'll make our code look pretty as we make our games. The second one down here is I'm going to take velocity, and velocity is what we're going to add to location, and so I'm just going to go down here and say this guy is going to take in dx and dy, which were my location. Now inside the vector location, vector has an X component and a Y component, so let's just take a look at that real briefly. If I come over here, notice that this guy takes in an X and a Y, so the X becomes this dot X and this dot Y. I'm sending in dx, but I'm receiving x. So the velocity vector is going to have an x and a y component, and the location is going to have an x and a y component as well. And so we can see we have some methods. We'll be talking about doing some of these methods. This is set magnitude, get magnitude, direction, and so forth. And we're putting all of these in, or not all of them actually. Most of them are going to go in the JS vector prototype. At least a couple of them are going to go directly into the JS vector. They're going to be what we call class methods or static methods. But in any case, for this purpose, right now, all we need is this basic functionality. I do need an add for this project. And so the add method we're going to use is going to say, it's going to take in a vector. We'll call that v2. So this vector, whichever vector is calling this code, whichever, so the location vector, for instance, is going to call this. If we pass in velocity, we get this dot x, and we just add the x components of the vector we're sending in to this vector. And the same thing for x and y. So anyway, let's go back to the bubble. All I have to do for this project is just change the, every place I see an x, for instance, well, not every place, let's see. I'm coming in here and down here. Oh, this is kind of messy. So this is the distance, and this whole thing here is how I find the distance. What am I doing? I'm using a Pythagorean theorem. I'm just taking the difference in the x's, the difference in the y's. I'm squaring those two values, adding the squares together, and then taking the square root. That's simply the Pythagorean theorem. But what I want to do is, using my vector class, what I want to do is simply take, we'll say this dot loc dot distance, and I have to write the distance formula in the vector class. The vector loc is a vector object, and so to go into the side of the vector object, I say use the dot operator dot distance, and I'm going to say bi dot loc. So I'm just getting these two location vectors, and the distance method is going to tell me the distance between these two things. So if d is less than the two radii, the radii of this thing and the radii of the ball that I'm looking at, then overlapping becomes true, and this dot color changes. So when they're overlapping, I change their color. That's really all that's going on. At the very top of this, on lines 21 and 22, I am saying that I'm setting the default color. So when I first come into this, I set it to default color, I set is overlapping to false, and I only change that back if the two are overlapping. And basically, on line 24, every ball is checking every other ball. Notice on line 25, I want to make sure that the ball that's using this code, which is this, on line 25 says as long as this is not equal to the I ball in the bubbles array. Okay, so that's that. Now down here, I need to go ahead and change these guys. So I'm drawing an arc, but I no longer have the x and the y components. There is no x property and y property in this. Remember, this is a bubble. And so what we have now is we have a loc dot. And so I'm basically changing this code so that we have this dot loc dot x, this dot loc dot y, and so forth. Down here again, this dot loc dot x, this dot loc dot y, and so forth. And that's all we're doing. We're just changing these from x and y components. This is going to be velocity. So we're choosing a random velocity here. So I need to say velocity.x. And I need to change this to velocity.y. Okay, so now I've got the x and y velocity are changing. Same thing down here. I need to change this to loc.x and loc.y. And then I'm adding to this. Actually, we made an add function. So all I have to do here is say this dot loc dot add, and I'm going to pass in this dot velocity. Okay, so that does it. If I have my add function working correctly, I'm just going to choose a random x value and a random y value for velocity, and then I'm going to pass that in down here on line 59, and that's it. So let's see, add get new. Let's see, this should be a distance. Here it is, distance. So what is the distance going to do? It's simply going to go ahead and take, let's see, I'll break this up into 3 lines. I think that might be easier to see. And so what I'm going to do is I'm going to call it, let's say, xdist. So that's the, that'll just be the difference in the x value. So we have this dot x minus v2 dot x. And we'll do the same thing for y. We'll call that ydist. And so ydist is going to be the vertical distance of one edge of, let's say, the right triangle. So we just change that to y and that to y. Once I have those two guys, this will make the expression a little bit simpler, but I want to return this, and I'm just going to say math.square root. And so what I want to do is I could just say xdist times xdist, but let's go ahead and say math.pow, which is a math function. It's going to take in a power. And what I want to do is simply take xdist, and I'm going to raise that to the power of 2. And I want to do the same thing to the y value. And so I take this whole chunk in here, and I'm going to go ahead and say ydist. And so I could put these two expressions, lines 89 and 83, could have actually just gone directly into this thing. But that's going to give me the distance between these two locations, the location of whatever vector I'm passing in, and this, which is whatever vector is calling this function. Okay, let's see if this works. And wow, that does not look good. That's not certainly what I was expecting to see. And I have no mistakes in the console. But it appears that all the bubbles, that looks like all of the bubbles located in the same place. So let's just take a quick look at that function that I just wrote. Let's see, I got v2, this dot x distance equal to this dot x, minus. I put equals. That's not very good. So let's go ahead and try that. Run it again. Okay, and voila. So every time the two bubbles get close to each other, they're going to overlap, and they change color, and that's it. So now we've changed everything with vectors, wrote a couple of simple vector functions, and that's it for today. Bye-bye.